Hey everybody, back with part 2 of this Sinistar repair. There's a color RAM issue on this board, and I'm going to cut in the end part of my last video showing the symptom, and then we're going to come back and look at the schematic here.
Alright, let's see what we get. Now obviously I don't have sound, but hopefully we don't have any lines. Oh, it's still got a weird, it says all systems indicate okay. What the heck is okay? I don't know, I guess that's normal, I think, on the top and bottom for the Williams board, the overscreen. Does that look normal? The color seems a little off to me, but initial test indicate all systems go. I don't know why. Does that look not as bright as normal? Maybe it's because I have too much light on. Seems a little dim. I mean, it seems like it's playing okay. Yeah, and it's got a C, backward C on the ROM LED. I mean, I guess it's working. I wonder if I want to measure the outputs. Obviously that high score table is totally jacked up. All ROMs okay. So I had to crank it. I normally don't have to crank up my contrast. It's kind of like a little dim. No RAM errors. No CMOS RAM errors. Obviously I don't have anything else hooked up. Color RAM test. That's weird. Color RAM test does not look right. See, that's going, yeah, it's missing a color. It's missing red. All right. Let me check the colors here to see what's going on there. Got something else to fix because something's not right. It's either one of these transistors or something. See if there's anything super hot here. Yeah, see, now all of the RAM is warm. Like literally these RAM that were bad were just cold as ice. They weren't hot at all, and they should be, you know, a little bit warm, obviously. Alright, I'm done messing with it for tonight, though. I'm gonna have to come back and look at that RAM issue. I mean, I don't know, something to do with the color lines. Look at the schematic and stuff.
Alright, hopefully you guys can see this okay. Up here on the schematic is your red, green, and blue. And I think, you know, there's something going on here because it's either with one color or with all three. I'm not sure. But when we have the color RAM test happening, it's like actually like blanking out. It should be three, you know, different levels of intensity of red, 3 different levels of intensity of green, 3 different levels of intensity of blue. Those lines, well, I guess they come here. There's red. Okay, yeah, it's not, the 6E is not involved at all. So they come into these transistors. There's red, green, and blue. These are 2N4403s, and then you see the 3 different data lines, which I think have to do with the 3 different intensities of each color, maybe? Is there only 2 in blue? I'm not sure, because there's only 2 lines there for blue, whereas there's 3 for green and 3 for red. That's kind of interesting. There's obviously some diodes and resistors and transistors, and then this 74LS374, and that gets fed in from 2 7489 RAM, which is probably pretty fast but low. You know, that's just like what I think that's what the color RAM is. So it's obviously testing this, and those come into this inline. I forget what you call it. It's not a resistor pack, but it's a SIP package, I guess, of resistors. I can't remember. But that comes in. One of the other things I wanted to highlight here, and I read this on the forums, is the screen control over here goes to pin 23 of the 7641. This is like a bipolar prom or something at 3C, and it goes to pin 23 of 3G. So 3C is your video decoder, or I don't know, video prom address bus. So it's getting addressed here, and these are data lines. And where does that actually go to? Video address bus, which is the video address bus is basically your counters and your counter chain. So I mean that should match. I mean, we should be able to actually just put a frequency counter on that and just see if it looks right for your video address. And then actually I could do signature analysis on this as well. I don't know if I did that or not in the past to check 3C, but since I have a spare, I could probably just swap it out. These are socketed, so I can't really swap out much stuff. So it's got to be in this area, like this, either this video, it's got to be these transistors or the LS374 or the video RAM itself. But let me look at it, what this looks like on a good board first. This is my good board, as you can see right here. And I'm just going to go into the test menu and get to the color RAM test. Right there. Red, 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 green, 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 blue, blue, red. Yeah, see, like I said, there's only 2 intensities of blue. I have my oscilloscope over here, and I'm going to come to these output transistors and just see which color is what. So that's green. There's blue. Okay. I'm going to let it go cycle again, because you can see the different intensities based off of the oscilloscope, like how high the level goes. There's 1, 2, boom. Alright, so that first one is blue, that first transistor. And then we're going to come right here. That should be red, I think. Red, red, red. So it went up each time, right? And then we'll come to green. Some people say, oh, do you need an oscilloscope to troubleshoot? No, not really, but like logic probe isn't going to catch that behavior, which I found kind of interesting. When you're doing the color RAM test, it's actually, you know, driving different data lines probably for the different intensities, and you can see that. So that's what the transistors look like. I need to look to see which one's the collector and stuff like that, and that comes from, these are the diodes and resistors, all part of that, and there's that resistor SIP thing going on. I just wanted to check these. That's just so I have something to compare to. Like, that's the resistor pack. Resistor pack. It's not a resistor pack, whatever, SIP or something. So if you can see that. That's red. I mean, it doesn't matter. They're all doing the same thing. Then we have 3C.
I think, right? 3C is the video thing. Let me make sure. Yeah, it wouldn't work if those were wrong. One's an address decoder. I think they're both address decoders or something like that. But one's for the video address bus and one's for the regular address bus. Let me see what else I want to measure real quick. All right, we're going to check this 3774 LS 374. It's upside down. I can't see it. But anyway, I just looked at the schematic again and I wrote down basically what pins go to what. And we're still on our cycle, and this is our working board. But I'm going to come to pin 19. We're going to watch our oscilloscope when it gets to red, because this is on the red line. So red, there's a little adjustment, goes to 0 on the middle intensity. So that's what pin 19 does. Goes low on middle intensity. Pin 2 is another red line. We'll watch what it does. Low, low, high. So yeah, so depending on what intensity, the color is, the other two lines are probably either low or in between, or at some different stage to basically drive the transistor appropriately, I guess, because it's being pulled high by this resistor, I'm pretty sure, from the output here. I'll double check the schematic real quick. But anyway, you should see some type of behavior like that on all these outputs when running this color RAM test. Right, I got my TTL book out right there. This 374 is a positive edge triggered flip-flop. And basically, I don't even know what that means, but I guess pin 18, for example, is tied to pin 19. So whatever 18 is, it should flip, the signal to the opposite side, I think, is what that means. The output control does not affect the internal operation of the latches or flip-flops. That is, the old data can be retained for new data, can be entered even while the outputs are off. Interesting. But anyway, let's look at the schematic here. Output, enable, and G are always grounded. Is what I see there. G, and clock is 6 megahertz. And so it's kind of like what comes in 18, 19, and then that has to go high, I bet, because it has to, this is like I think that's a Zener diode, right? So it has to go over that threshold. Yeah, I'm pretty sure that's what happens. And these on the input side are tied high, or pulled high, so that they don't go down low, because if it goes low, then this will go high, I think, and cross that threshold of the Zener, which will then output here. I think that's what's happening. So let's look at, I think I have enough. I'm going to put the old board back on the problem board. I got the non-working board, and it is running through the color ramp test, even though you can't see it because it's blank there. And we're just going to come to what I believe is the collector. Is it the collector? Yeah, I'm pretty sure this is the collector side. And we're just going to watch that. Now you can see, well, it's very quickly, but it's not, we're not getting the kind of vertical amplitude, what we're expecting based off of the previous board test. Like, it's trying to go low, like now it's low, and then it goes high. Oh, am I holding it right? What the hell's going on? Why is it low all the time? Actually, I don't know. I thought it was high, and then it went low. There we go. Yeah, kind of weird, right? That might be green. I can't remember now. Red. And then it turns off. Something's not right. But for some reason, I don't think it's those transistors. Because all three of them being bad at the same time, they all have the same behavior on that collector side. Just seems weird. Let's see. And I checked this. Let's check pin 19. See? It's behaving. The 374 is behaving normally. If I come to pin 18 is the input side. I mean, it looks like it's behaving correctly, but it's got to be somewhere else. Yeah, see, here's the 374, and it's, driving the line low, which is fine. That's coming from the color RAM. Drives the line low. That drives that high, and we see pin 19, kind of behaving normally. That comes into the base here, and that's where the output for this collector here, because this is a PNP pointing in proudly, so this is the output, and that's what we were seeing. And the input is all tied together. See, the emitter, which is pointing in, they're all tied together, and they come from this Q4, which is driven by this 4B pin 11. Let's look at 4B pin 11 and then the collector of Q4. All right, 4B pin 11, 8, 9, 10, 11. That looks good to me. And then if we come to Q4, I should see something very similar, right? But look at that. Does not look right. That's just high. I don't know. I'm focused on this area. I might try swapping that out. All right, I pulled all the transistors and did a diode test on them, and they all test fine. So then I put my working board back on just to probe some good signals again, see what we look like. Got my color RAM test on, just like that. We're going to come to 4B pin 13, which is one of the inputs. And I got, that's probably horizontal sync, 15.6 K, or almost 14.7. And then pin 12, 60 hertz, if you can see that over there. And then the output is pin 11. And you can see that looks, almost a full 0 to 5 volts there. Speed it up just a little bit. Pin 11. See, that's 13, 12, 11. About 50. It's cycling between. It's like a combination or something of 60 hertz and 15.7 or something like that on 4A. So let me hook up the bad board again and see what we see. I think I might be on to something. I'm not sure. So non-working board. I'm not going to go back and refilm it, but the 4B output on pin 11, it wasn't quite getting up to 5 volts. I mean, it just seemed a little off compared to my other one. And then I started measuring the resistors that it was coming to, which comes into right here. So if I already desoldered this and lifted it up. So if I come here and go to 4B pin 14, 13, 11. Yeah, you can see. Alright, that's continuity there. And then if I put this resistor back in, actually before I do that, comes into this resistor, which is 470 ohms. You can see that's measuring 468. And then that resistor gets tied to the one next to it, which is a 1K resistor, which goes to 5 volts. So that's fine. But if I bring this in, put this thing in there, my eyes are so bad now. I'm just going to press it to the side so I make some contact like this. And then 14, 13, 12, 11. Okay, yeah, duh. You need to come over here. See how it, I know the connectivity is not perfect there, but it's like 414 ohms. If I can, because I don't have it soldered in there, kind of have to hold it. Or actually, I'll just hold it here and show you. See how it drops to 414 ohms? It's like there's some resistance within this chip that's dropping it from 470 even lower. And this is a Fairchild chip. I think it has an F on it or something. I just think that 7400 is bad. Even though I had activity on the output, it looked fine. The inputs looked fine. The output was just a little off. And I just have a feeling that's our problem. So I'm going to swap it out and come back. Alright, I got the 7400 replaced, or socketed anyway. And I haven't powered it on yet. I'm going to do that with you guys. But I'm going to come to this part of the resistor, 14, 13, 12, 11. Much better. We're at 468 ohms versus 417, which I think bodes well for us. So let me go ahead and power this thing on. See if I got everything. Much better. I can tell that's fixed it because the colors look much better. What a pain in the butt that was. Let me hit my test switch. Color RAM test. Here we go. Boom. 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 Yeah. See, we're working now. I need to still do something, and this is the base of that. And see, that's what we were supposed to seeing on that base. We weren't seeing that on these collectors of these transistors. What were we getting before? I can't remember. So yeah, we weren't getting that. Alright, well that's color RAM test is fixed, and I'm calling this board fixed. I actually don't have controls to actually test this interface board. Is it the same as any other interface board? I could put it in my Robotron, I guess, and test it out if it's the exact same. I think it is. I might do that. I might put it in one of my other cabinets just to make sure it works. Damn, I don't want to do that. Alright, if I don't come back, that's it, guys.